We have an ionic compound plus another ionic compound, which makes this a double replacement reaction. Now that we know that it's a double replacement reaction, it's going to be first and last get together. First is magnesium. Do not carry over subscripts, but it doesn't have one. And then last is sulfate, which is this SO4 inside of the parentheses. I will carry over the 4 because that is part of the sulfate formula, SO4, but I will not carry over the 3 because that came from balancing charges. Now, speaking of balancing charges, magnesium has a charge of +2 and sulfate has a charge of -2. So +2 and -2 are going to cancel with one another, and so now this formula is completed. The last formula is third, which is aluminum, and second, which is the bromide. I will not carry over the 2, and I will also not carry over this 2. We want to balance the charges between aluminum and bromide. Aluminum has a charge of +3. Bromide has a charge of -1. So we're going to take this +3 and this -1. And for them to be balanced, we're going to need a 3 here because 3 times -1 equals a -3, which will balance with that +3 there. So now that I have my products written and balanced, I can now balance the coefficients in the equation. 1 magnesium, 1 magnesium, 2 bromines versus 3. The common factor of 2 and 3 is 6. So what I want to do is write 2 times 3 is going to give me 6 bromine. 3 times 2 is going to give me 6 bromine. Now this has modified my magnesium. I now have 3 magnesiums on this side. So I'm going to put a 3 here. That's going to give me 3 magnesiums here. Now 2 aluminum, because that's what this 2 here is going to give me. And finally, I want to balance my sulfates. I'm going to circle the SO4 on both sides of the equation to balance it as a bundle. On this side, there are 3 sulfates. And on this side, there are 3 times 1 equals 3 sulfates as well. So this is now officially balanced. Final answer is magnesium bromides reacts with 1 aluminum sulfate to form 3 magnesium sulfates and 2 aluminum bromides.